Hello, welcome to my video in ultrasonic testing. Without further ado, let's jump right into the principles. So ultrasonic is a sound energy above the audible frequency of 20,000 Hz. Due to its high frequency, it has good penetrating power. When this sound energy is introduced and propagates through a material, it could either hit a back wall or a floor where it will be reflected back up and into the transducer. The reflected signal can then be sent up to a display where you can see the result. So this is the display for this example. There are three phases here. First one, the initial pulse from the transducer. The second one, the floor reflection from this one. So the units of time here is 4, but in reality it's actually 2, but it's 4 because it's reflected down and up. So 2, 2. So the same goes for the back wall, which is 8, where it goes slightly further down and up. So this is an old method, but it's still very useful up to now to detect flaws in a material. Hello! Alright, so on to the next segment. I'll be covering the technique for ultrasonic testing. Right here I only have 4 displayed, however there are definitely more than 4, but it's still lengthy, so you can check the rest at the website. So the first technique is the straight beam. I actually used this technique to demonstrate the principles earlier on. So sound energy is introduced into the pot, and if a flaw is detected, a lower amplitude will be displayed on the visual display. Alternatively, it can be used to measure thickness of a part. So instead of a display like this, it could be in numerical form, so in this case 1 inch. So on to the second technique, angle beam. It roughly follows the same principle as the straight beam, however it's mounted on an angled wedge, also called the probe. So this probe in this case is 45 degrees, and if a sound energy is introduced and no flaw is present, it will actually just reflect off and no reading will be received by the transmitter, or the transducer rather. However, if a flaw is present and generally perpendicular to the sound beam, the sound beam will reflect into the transducer, and similar to the straight beam, there will be a spike in the phase. Yeah, and that's when a discontinuity is present. So third one, immersion testing. I actually really like this one, it's pretty cool. So you can measure in X, Y, and Z axis. So there's a swivel here to move the part like this and like this. Right here you can also swivel the transducer. So if this is a transducer, it can go here and here, and this is a bridge, so it goes up and down. All of this is immersed in in a tank with water usually, and roughly similar principles to angle and straight beam. Through transmission, unlike the others, uses a transmitter and a receiver instead of just a transducer. So if sound energy is introduced from the transmitter, it will be received by the receiver on the receiving end. Yeah, tongue twister. So if a flaw is present, less sound energy is received by the receiver, and it will be displayed on the screen a lower amplitude. Alright, so I'm here in the NDT lab, and I'll be doing the ultrasonic testing, a live demonstration. Yeah. So our goal here is to calibrate this block. We'll find the thickness of this one, which is 0.75 inches, and this one, which is 1 inch. Then, once we've calibrated, we're going to find the distance from here up to the individual holes. So here's A, B, C, and D. Alright, here's another look. Okay. So the equipments will need a coolant, of course your ultrasonic testing device, your charger, and your transducer. Alright, so once you've got all your equipment, you just stick in your charging jack and plug it in. Alright, once it's in, just switch on your device. Alright. Okay, so I'll give a beep, and once you've got that, you need to charge in, you need to plug in your cable. be sure to plug it in there, the TR. Okay, so now it's connected to your transducer. So now we're going to do a bit of setup. So you want to press gain and F2, which is 20. Alright, then you press enter. Okay. So delay 0. Range you want to put 2, so F3. Alright, press enter. Okay, then you press display setup. And for your base, alright, you go down to velocity. F3, 0.2490. Enter. 0, set to 0, so F1. Angle should be in 0, so just press. Yeah. And okay. As you can see, the range went slightly off again, so no problem. Just go to display. Enter. Alright. Yeah, just keep pressing enter. And range just bit to F3. Alright. So now your screen should look something like this. And from the base, you want to go to gates. Okay, let's press gates. Alright. And press calibrate. Okay, so now all this appears. Alright, so now you're going to apply your couplant onto the block. But before you do, take a clean wipe. Let's clean off the surface in case of any couplant or residue left from the previous inspection. So you want to apply some couplant there. And on the thinner one, there we go. So, pick up your transducer. Yeah, right here, put on the thin one. So, gotta let it go. So, what you gotta do is actually, you gotta press F1 when you're at gates, and just shift the gate right there. Press F4, auto 80%, cal thin. A measurement, something like this will come out. Well, for a fact, I know it's 0.75 as mentioned. So you just want to press down all the way to 0.75. Press continue. Alright, so you can just take that off now. Put on the thicker one. There we go. Okay. See, the gate is slightly off, so you want to measure. I shift that too, so I'm going to press up. Alright, auto 80%, cal thick, bring it down to 1 inch, press done, and there we go, we've calibrated it. So now we're ready for inspection on the 4 holes. Alright, so now to measure the distance from the top to the hole. Before you start anything, take a clean wipe again, just clean the surface. There we go. So now put your couplant on, directly above, by the way, to the best of your ability, of course. There we go. Alright, let me just take it back a little. Bit there, and a bit there. Sorry. Okay, so now we've got the couplant directly above. Pick up your transducer, put it on the first one. Up, and lift it up. So, whoa, a crazy reading here. Okay, so I'm gonna press auto 80. Auto 80. Okay, never mind. Alright, so shift the gate a little. There we go. Just make sure, press auto 80. And this 1.18 is the measurement from here up to here. So it'll be 1.18. Okay, now repeat it for all 4. Pick it up, put it on the second one. Okay, there you go. still within range. So auto 80, 1.20. Looks good. On the third one. Okay. Auto 80, 1.21. Alright. Okay. So now onto the last hole. Let's pick it up. Put it there. Directly above. Okay. So the reading. Alright. So notice that actually this hole is much higher compared to the rest. So this reading picks up. Right now it's at the third phase. What you want to do is bring the gate to the second one. Yep, the second one. And press F4 because this is actually the proper one, not the third one. So it's the second one. F4 and yep, that's your distance, 0.56 inches. Alright. So that is all for my ultrasonic testing video. Thank you for watching up to this far and hope you learn it.